everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 120s on your screen. Let's get started, please. That shouldn't take you long. Stay on it. Stay focused, because today we're moving on to the next portion of the rationals. Hopefully we can wrap it up already. All right? Copy and go. All right, so warm-up 120. Let me go over this really quick. I'm going to do the base 2 with blue. And f of 2 is 2 to the 2 minus 2, which is 2 to the 0. Any number to the 0 is 1. All right? Base 10. F of 1 equals 10 to the first, which is 10. F of 2 equals 10 to the second, which is 100. All right? Number 2, graph f of x equals x cubed. So x cubed, like this, should be crossing through the point of origin at 0, 0. And then they're asking us to move this. But before we move it, 4 to the right and 1 up, what does this do? Explain it to your neighbor. What does that do to the original function? What does it do? Yeah, that is correct. It stretches it. So instead of being like this, it's going to be a little bit tighter, like so, and longer. So once you stretch it, we move it 4 to the right and 1 up. So it should be somewhere over here. Number 3, distribute the exponent to both the denominator and numerator. So this is f to the negative 5 to the negative 2 over y to the 12. Now check this out. Y to the 12 is positive, so I leave it in the denominator. However, which one is the negative? The 5 to the negative 2, is that correct? So I bring that to the denominator, and it turns into a positive value. So since there's nothing left on the numerator, I'm just going to put a 1. Therefore, let's simplify. 1 over, what is 5 squared? That's 25. Y to the 12. All right, this is a to the x times a to the negative 9, which is a to the x over a to the 9. And last but not least, I'm bringing back the inverses. It says write the inverse and check. For right now, we're not going to check. Let's just write the inverse. What is the first step? We change f of x to what? To y. Y equals 1/2 x squared. Next, we're going to solve for x. That means leave x by itself. How do I cancel this half? Multiply times 2, or 2 over 1. So multiply times 2 both sides. This cancels. We're left with 2y equals x squared. How do we cancel that squared, everyone? Square root. So square root of 2y equals x. Am I done? No. What makes it the inverse? When we do what, everyone? We replace the variables. So this becomes square root of 2x equals 2y. And then in function notation, square root of 2x equals f inverse of x. There you go. All right, make sure you send that in. Here we go. Copy the agenda. Warm-up 120 done. Rational functions. Today we're going to be looking at discontinuities, or something that we call holes on the rationals. And tonight's home plate, 4 graph rational functions, 4 of them. Once you copy the agenda, go to Canvas, turn in your home plate. You had 4 graphs to do, so make sure you turn those in, please. and then get a Cornell note ready. We're moving on. Let's go. Go, Caesar. We got this. All right, once again, warm-up 120 done. Rational functions, we're working on wholes. And tonight you have 4 of those problems that you're going to do. And you turned in your home plate on Canvas already. And copy the code to access the home plate for tonight. Oh, hold on. There it is, KDXUL. KDXUL. Bless you. And the home plate, bless you. The home plate for tonight looks something like this. All right. So, Cornell note, here we go. I can write solving graph rational functions. By now, you should have remembered what rational functions are. So, remind your neighbor, what are rational functions? What are rational functions? What are rational functions? 1. All right. So, in your notes, you had an equation that contains 1 or more rational expressions. What are rational expressions? Fractions with polynomials. So you needed to write something like that in your own words. All right. So from there, we went from general rule to rational rule. And then we were talking about asymptotes. We went from vertical and horizontal to slant, which is the one you did last night. So here's a quick look back to all the rational functions we covered. Writing utensils down, look up to the screen. Here it goes. Quick refresher. We started off with f of x equals 1 over x, or anything with a 1 on top of the fraction. Is that correct? And these are transformed, and all of a sudden we got to these where we needed to do long division and rewrite it to look like these. Now, how do those graphs look like? Like this one, a positive graph with this graph down here and the other one up here. However, if it had a leading coefficient of a negative, what happens to the graph? It flips. Yes? So far so good? Yeah? From there, we went to these. Very similar, but now with square on the denominator. So if you follow this one with a 1 on the numerator, same thing. We just do transformations using the h and k. And this one, the -2 goes up front, and so on and so forth. But what does this graph look like? It's got 1 on top with a J, looking J, and the other one looking like an L. And that's for the positive. So that means if it's a negative leading coefficient, it flips. That's why it flips down like that. From there, we went to these, where we had 2 asymptotes, and all of a sudden you split up the graph like that, and yesterday's, which was a slant asymptote that looked like that. So far so good? Good refresher? Yes? All right. So today we're going to be talking about something called discontinuities. Discontinuities. In other words, you're going to hear this in mathematics. This is the proper term, but they also call them holes. Holes. So, without further ado, copy this one, example number 1. It says, rewrite the function and graph using and identify the asymptotes and holes. They give us g of x equals x minus 3 over x squared minus 5x plus 6. Then make a coordinate plane on the side, nice and neat. I'll give you some time to copy that. Couple minutes. Nice and neat, please. Go. All right, here we go. Y'all ready? Step 1, look up to the screen and follow along. Step 1 is this. I'm not going to say anything. You should know what I do. Before you copy it, look up first. Copy that. Bless you. And tell your neighbor one word. What did I just do? One word. What did I just do? One word. What is that one word, Joseph? Yeah, what is that called? Because I didn't use the Power Ranger on top. Very good. Factor. Very good. I factored the numerator and I factored the denominator. We're still not done with step one. Look up. So step one, we start off with what? Factor. Next, look up. Tell me what I just did. One word. All right, what did I do? Joseph. Very good. Simplify. So step one, we started with factor, then we simplified, and we rewrote our equation right here. There it is, our function. This is our new function. So on the side, I want you to write step one, factor, simplify, rewrite. All right? So now, if I was to ask you to graph this, you should know how to graph this by now. However, writing utensils down before you continue, let me show you something now that is new. Writing utensils down, look up to the screen. What did we just take away from the entire function? X minus 3, is that correct, from top and bottom? Well, guess what? This is what we call a hole in our graph. What does that mean, Mr. Q? That it's going to become a hole because we took it out from the function. So how do we find our hole? Well, we write whatever we took out only once. So we write x minus 3 and we set it equal to 0. Solve plus 3 plus 3. Just pay attention. You'll copy right now. X equals 3. So that gives me a coordinate of x equals 3. But now I'm missing a y coordinate for my hole. Where did I get my y coordinate or my g of x? Oh, from the new equation that we have. So the new equation that we have is what? G of x equals 1 over x minus 2. But instead of x, what am I going to use, everyone? 3. That is correct. So g of x equals 1 over 3 minus 2 is 1. What is 1 over 1? 1. So my hole is going to be at what? 3, 1. So check this out before you copy. 3, 1 is right here. To show that it's a hole, I'm going to make a little circle like that, like if there's a hole there. So copy that, please. So step 1 was factor, simplify, and rewrite. Step 2, I want you to write identify or ID hole. Identify the hole. And lastly, step 3, graph. And how do we graph that new function that we have here? Well, Mr. Q, we need a VA and an HA. So look up. So we are here at our new equation. Once it's simplified, we are here. And we're going to graph that. So we need a VA. X equals. Tell your neighbor what the VA is for that one. What is our VA? Let's see. Who haven't I called on? Joseph! What's our VA? 2 is correct. All right, but we need an HA. Study neighbor what the HA is, please. What's our HA? Joseph, pass someone. Mario. 0 is correct. Okay, let's graph those asymptotes. We got 1, 2. And then we got 0. All right, so look up. Here goes the graph. Where do both asymptotes intersect? Look up. They intersect here. Why do we need to reference that, Mr. Q? Because now we can graph it. Where do we have one of the graphs? We go one to the left and one down. There's our graph right there. However, we go one to the right and one up. You're like, wait a minute, Mr. Q, but I can't place a point there. No, why not? Because it's a what? A hole. However, the graph should still pass by it like so. And then make sure you label that hole. Do you guys see a hole in your graph? Yes? That's how we find the holes. From 1 to 5, I'll come to where you with it so far. 5 fours, 5 fours, okay? Let me send you the screen so you can send me your notes. All right, not bad, not bad. Let's see if you can do one by yourself. I mean, we're going to do it together, but I'm going to give you a head start. Here we go. Example 1Q. Write that down. G of x equals x plus 2 over x squared plus 3x plus 2. Go through your process, and then I'll give you a head start, and I'll catch up. Make a new coordinate plane to the right or to the left of your function. I'll give you a head start. Go. All right, let's see where we're at. Step 1, we're going to start by factoring. So we got g of x equals 1 times x plus 2 over that's 2 and 1. So my factors are x plus 2, x plus 1. So far so good, yes? Simplify and rewrite. 1 over x plus 1. Hands if you got that by yourself. Okay, we good? Next, we need to identify our hole. What did we take out? X plus 2, we set that equal to 0. Minus 2 minus 2, x equals negative 2. So for my coordinate for the hole is negative 2. We need a y1. So that means I'm going to bring this, and I'm going to write it over here. G of x equals 1 over blank plus 1. But instead of x, I'm going to write negative 2. So g of x equals 1 over negative 1. What is 1 over negative 1? Negative 1. So my hole is at negative 2, negative 1. Right there. Check your graph. Hands if you got that by yourself. All right, not bad. From there, we take our now new function. We're going to graph that, which means we need a VA, x equals negative 1, and HA, since there's nothing here, that means f of x equals 0. So, x negative 1, and f of x equals 0. So to graph that, from here from the center, 1 to the left, 1 down, there's a hole there, but I can graph my little graph passing through the hole like so. 1 to the right, 1 up. There you go. From 1 to 5, how comfortable are you with this so far? 4 5s, 4 5s, okay. Send me your notes really quick. Hold on. Let me say. All right, so I did one. You took notes. You did another one, and then I came back and I double-checked to make sure you got it. And that brings us to, let's see, to this one. Copy this one, please. Example 1, super cube. X squared plus 7x plus 12 over x squared plus 4x. All that equal to g of x. All right. I'll give you a little head start. Go. And then where you get stuck, wait for me. We'll elaborate together. All right. So, let's factor this. We got g of x, and then we got 12 and 7. That's 3 and 4. So x plus 3, x plus 4. GCF for the denominator is x, so we're left with x plus 4. And if you got that by yourself, yeah, so far so good. Next, giant 1. So our new function is g of x equals x plus 3 over x. Wait a minute. What? Did everybody get that? Yeah? But wait. Aren't we supposed to get one with a 1 on the numerator? Yes, Mr. Q? So what shall we do? What do you think we should do? Talk to your neighbor. What do you think we should do from there to continue rewriting that? Mario, pass him one. Enrique, what do you think we should do? No? Can't just switch it. Let's see, help him out, Caesar, what do you think? What did we do on the previous ones when you had something like this? What did we do? Long division, Mr. Q. Oh, okay. Long division. So, what number times x equals x? 1. 1 times x is x. Subtract. Cancels. Bring down the 3. And that's our remainder, yes? So, what is the answer for this? The answer is 1 plus the remainder, which is 3, over, what's my divisor? X. However, we move the 1 where, guys? Bless you, to the end. Bless you. How about the 3? The 3 goes where? In the front. So we got 3, fraction bar x. We move the 1 to the end. And on top, we just put a 1 right there. So this is our new transform function. So we can graph this. However, didn't we take out something from the whole thing? Yes, we took out the whole. So let's identify our whole. So let's bring that down here. Right whole. Our whole is x plus 4 equal to 0, minus 4 minus 4, x equals negative 4. And then I'm going to use this new one, which is g of x equals 3 times 1 over x plus 1. But instead of x, I'm going to write what? Negative 4. So 3 times negative 4 is 3/4, and it's a negative. Plus 1. What is 1 minus 3/4, everyone? 1 minus 3/4 is, Elijah? 1/4, yeah, 1/4. So let's graph our whole. Negative 4, 1/4. Right there. And now let's graph our new function, which is this one. So, VA x equals what? Tell your neighbor what the VA is. What is our VA? Is there anything next to the x? Therefore, the VA is what? 0. What is our HA? HA is what, everyone? 1. That is correct. All right, so let's get our asymptotes there. X, 0. And f of x, 1. All right. Now check this out. Look up, guys. Where both intersect is here. So if I was to graph my graph going 1 to the right and 1 up, but wait a minute. Am I only doing 1 up? No. What is this? How many steps, people? 3. So 1 to the right, 3 up. 1, 2, 3. But this is what I want you to do. Bring it close to the asymptotes. And then from here, 1 to the left, 3 down. 1, 2, 3. Now check this out. It goes through that one, but it has to go also through the hole. Don't go through it, but make sure it passes by. There you go. How we doing? From 1 to 5, how come through are you with these? Where are we at? 1 to 5. 5 fours, 5 fours. All right. 23. So yeah, so the only difference, guys, with these, whenever you do the factoring and you get the giant 1 out of the way, if you end up with another function that you don't have a 1 on the numerator, what do? Long division, rewrite, and that should give us the function now with a 1 on the numerator. Okay? All right? So with that said, send me your notes. All right, so I'm going to give you one just like this so you can do by yourself. Let's see how you do the whole thing. Here goes. Example 1, super duper Q. G of x equals x squared plus 5x plus 4 over x squared plus x. So, rewrite, find the whole, graph the whole thing, and then send me your notes. I'm going to send you the screen in a little bit. I'll give you some time. Copy and go. All right. Send that in, please, and let me go over this as you're sending that in. We should have gotten g of x equals x plus 4, x plus 1 over x, x plus 1. By doing Power Rangers on this one. Giant 1 is right here. We end up with g of x equals x plus 4 over x. We do long division. x plus 4. Fits in there one time. Remainder of 4. Answer is 1 plus 4 over x. However, this becomes 4 times 1 over x plus 1. Then we work on the whole. X plus 1 equals to 0 minus 1. X equals negative 1. Substitute that in here, so we get g of x equals 4 times 1 over negative 1 plus 1. That is 4 times negative 1 plus 1. That is negative 4 plus 1, which is negative 3. So negative 1, negative 3, there's our whole right there. And of course, we're going to use this one to graph our function. VA, x equals 0. HA, f of x equals 1. So, from here, I'm going to go 1 to the right and 4 up. Why 4, Mr. Q? Because of that. 1, 2, 3, 4. And then 1 to the left, 4 down. 1, 2, 3, 4. There's a hole there, so that means I do this. There you go. Hands if you got that by yourself. All right, from 1 to 5, I'll come to you with these. Yeah, we got it, right? 5 fours, 5 fours. That's going to be your home place, so go ahead and send me your notes. Log out after that. Those of you following along on YouTube, make sure you put some practice in. See you guys next time. Peace.